A massive dark scar has returned to the surface of the Sun, not once, not twice, but 3 times. It keeps coming back, defying the physics of solar life cycles, outlasting its peers and edging closer to a record set before the television was even invented. This is no ordinary sunspot. This is AR4100. When most sunspots vanish in days or weeks, AR4100 is different. It's resurfaced 3 times, circling the entire Sun, rotating back into view again and again. This puts it on the brink of surpassing a record that has stood unchallenged for over a century. But this isn't just about breaking records. The longevity and behavior of this single magnetic region could reveal new insights into the inner workings of our star. Insights with real-world implications for everything from satellites and communications to future space missions. It also raises profound questions about what else may be lurking beneath the solar surface, undetected, invisible, but waiting to break through. Could AR4100 be part of a larger pattern? A signal that we're entering a phase of more powerful, longer-lived magnetic activity. Sunspots are born from magnetic disturbances rising through the Sun's convective zone. This is where hot plasma churns like boiling water, driven by immense heat from the Sun's core. As magnetic fields twist and intensify, they can punch through the photosphere, creating localized regions where energy flow is suppressed. These appear dark because they are slightly cooler than the surrounding areas, though still thousands of degrees Fahrenheit. AR4100 began its life as AR455 on April 5, 2025. After completing its first visible journey across the Sun's Earth-facing side, it disappeared over the solar limb. On April 28th, it returned as AR4079, and now, for a 3rd time, it has emerged again, reborn once more as AR4100. This renaming follows standard solar tracking procedure. But make no mistake, it's the same sunspot. Its shape, size, magnetic polarity, and latitudinal location have remained consistent across all 3 appearances. AR4100 is enormous, over 87,000 miles across. That's enough to fit Earth inside it 11 times over. Its sheer scale makes it visible even to backyard astronomers with proper solar filters. And with each new pass, it's become a fixture of interest for observatories across the globe. Data from NASA's Solar Dynamics Observatory and the European Space Agency's Solar Orbiter show that AR4100 isn't just large, it's magnetically complex. Massive loops of charged particles known as solar prominences arc high above it, revealing the twisting fields beneath. These loops trap plasma in glowing arcs, each one sculpted by the sunspot's powerful magnetic forces. Its return has also allowed scientists to study how solar features evolve over time. Remarkably, AR4100 has retained much of its structure. The main umbra, the darkest central core, remains strong and sharply defined, while the surrounding penumbra shows little sign of degradation. This is highly unusual. Most sunspots decay quickly due to solar shear forces and convection, but AR4100 remains firm, almost untouched by the Sun's internal chaos. Ordinarily, sunspots this large behave like loaded cannons. Their tangled magnetic fields twist and snap, unleashing solar flares and sometimes massive coronal mass ejections, vast plumes of solar plasma hurled into space. These events can wreak havoc on Earth's technology, disrupting satellites, aviation, and power grids. Yet AR100 has been oddly quiet. It has produced several M-class flares, strong enough to impact radio communications, but not a single X-class event. And critically, it has not been associated with any major coronal mass ejections. This level of restraint is surprising for a sunspot of such magnitude. One possibility is that AR4100 is in a state of magnetic equilibrium. Its magnetic loops may be so evenly balanced that they are unable to break and reconnect, at least not yet. If true, it means AR4100 is storing enormous energy without releasing it. That alone makes it potentially more dangerous than it appears. Some researchers speculate that the sunspot could be anchored unusually deep, perhaps rooted in the tachocline, a thin boundary layer between the sun's radiative and convective zones. This region is believed to play a critical role in solar magnetism. If AR4100 is connected to it, that might explain its resilience. Helioseismology, which uses acoustic waves to probe beneath the solar surface, shows persistent flows associated with the sunspot. These subsurface signatures reinforce the idea that AR4100 may be tapping into a more stable layer of magnetic energy, a phenomenon rarely observed. Its longevity also offers a rare opportunity, the chance to track a single magnetic structure across multiple solar rotations. This helps researchers test and refine models that predict sunspot evolution, solar storms, and the life cycle of magnetic fields on the sun. And then there's the historic comparison. The last time a sunspot persisted for 4 full rotations was in the year 1923. AR4100 is now knocking on the door of that century-old record. If it returns again in June, it may surpass it, becoming the most persistent sunspot of the space age and the most scientifically documented, long-lived sunspot in human history. AR4100's unusual endurance forces us to reconsider what we thought we knew about sunspots and about the sun itself. For decades, models have assumed that sunspots are inherently short-lived. Magnetic turbulence on the sun's surface, combined with chaotic convective flows, should tear these regions apart in a matter of days. But AR4100 challenges that assumption. It has not only survived, it has thrived. This matters because sunspots aren't just solar scars. They are surface indicators of vast invisible systems beneath the sun. Studying AR4100 may help scientists detect and classify other long-lived magnetic regions, ones that could have a massive impact on Earth's space weather environment. With solar activity ramping up in solar cycle 25, understanding AR4100 could help us better prepare for future flare seasons. And on a broader scale, it could also inform how we interpret stellar activity around other stars. Many exoplanet-hosting stars exhibit flare behavior linked to spots. By studying AR4100, we may uncover patterns that apply across the galaxy. Its lack of eruptive activity also suggests a category of quiet giants, sunspots that are massive, magnetically stable and persistent, but not explosive. Recognizing these could be crucial in assessing space weather risk, both here and elsewhere in the cosmos. AR4100 may even help redefine what qualifies as an active region, a term long used to identify potential flare zones. If stability is more dangerous than chaos, because of the potential energy buildup, we may need to rethink how we monitor our star. As AR4100 moves toward the edge of the Earth-facing solar disk, all eyes are on the far side. Will it return again in June? If it does, it will not only tie a record from over 100 years ago, it will break scientific ground in the modern space age. Either way, it has already left its mark. A colossal, magnetic reminder that our sun, though familiar, is far from fully understood. For more true science stories like this, subscribe now, because the next sunspot might be even stranger.